Hi viewers. Um, in today's video, we'll be talking about measuration. Measuration, which we all know, is the study of calculating or measuring the areas, perimeters, and volumes of shapes. So, without wasting much of our time, I won't be taking time to be describing the shapes and other things. But if you really need the explanation of the types of shapes and the other things, you drop it in the comment section, so I will know what you like. So as for today's video, I'll just be bringing shapes and giving the formula and solving examples of question under them directly. So for the first one, I'll start talking about triangle. We all know what a triangle is. A triangle is just a polygon bounded by what? By three sides. So the area of a triangle is given by 1 over 2 base times what? Height. So for instance, you are given a triangle that looks like this. This is just a triangle that has a side, let's say 1, then this side is 2. Yeah. And you are told to find the area. Let's assume you are told to find the area of this very triangle. The area is going to be, like we said, 1 over 2. What is the base? The base is just 1. So 1 times what's the height? The height is what? 2. So the area of this very triangle, 2 will cancel 2. This is going to be 1 centimeter square. Sorry, I didn't insert the unit. This is 2 centimeter. So this is just the area of this triangle. So let's solve one more example. Let's assume you have just this right angle triangle and you are given 2. Sorry, I'm still missing the unit. 3 centimeter, 2 centimeter, and you are told to find the area. The area of this is just going to be uh 1 over 2 base, which is 2, times what's the height? 3, which is equals 2 times 3, 6. 6 divided 2, this is going to be 3 centimeter square. But this is just a simple way of calculating the area of a triangle. Let me refer you back to Pythagoras theorem. And we all know Pythagoras theorem is just a method of calculating the missing side of a rectangle triangle. Because you can be given a triangle that is not of this form. Let's assume you are given a triangle of, let's assume it's this. I just given this. And let's say this side is 1, uh, let's say 2. I'm trying to assume that this side is same. Pardon me for, I don't know how to draw very well. This is 2, 2. Then this base is just, let's say the base, let's call it 2 as well. This is an equilateral triangle. I'm trying to assume it's an equilateral triangle because 2, 2, 2. So if you are told to calculate the area of this triangle, how do you do that? Because normally this one, we know the height. But if you look at this, this is not actually the height of this triangle because it's somehow slanty. So the height exists here. How do you do that? How do you get this height? That's why I brought about Pythagoras theorem. So Pythagoras theorem, to brief you on that, in case you are not familiar with, to brief you on Pythagoras theorem, if you are having a right angle triangle, let's say this is A, B, and C. If C is the missing side, the formula is given by C square is going to be the sum of the other side, A square plus what? B square. If it is B that is missing, it's just to make the other part subject of the formula. Making B subject is just going to be B square is equals C square minus what? A square. To calculate A square is going to be C square minus B square. So looking at this very well, you can decide to like split this into 2. If you split this, if I cut this part, the whole of this, the whole of here is our what? This is the base. The height is what is missing. So if the whole height was 2 and I split it into 2, this part is going to be 1, this is going to be 1. 1 plus 1 is still going to be what? 2. So for this, I think I'm going to have some kind of a triangle. I'll have something like this. This side is 1, this is 2. Something, this is, let me call this A. Sorry, I wanted using X. This is A. Same thing with the other part. If I'll cut it 2, I'm going to have this side to still be my A. This is 1 and this is what? 2. Because if you join these together, you're going to have the same shape here. So how do we do that? And normally, we all know what area is all about. Area is just to calculate the size of a certain portion of a subject region. So right now, to calculate the area of this, if I calculate the area of this portion and sum them, I'm going to get the exact area of this equilateral triangle. So looking at this shape, this is just a right angle triangle with a missing side A. And looking at this, what did I say about how to calculate the missing side A? Is just to put A square equals C square minus B square. This is just a constant formula. So for this, A square is equals, what is our C square? Looking at this, C is what? C is 2. So I'll put 2 square minus, what is our B square? B square is 1. So 1 square. So A square is equals, 2 square is what? 4. We have 4 minus 1. Because 1 square is what? 1. So I'm having my A square is equals 4 minus 1. This is 3. So that A is going to be what? Square root of 3. So that means the missing side is what? 3. This portion is square root of 3. And you all saw how I calculated it, right? So since the missing side is 3, how do we, if I bring back this, that means this figure is going to be something like, sorry, I think I should try and learn how to draw. The whole of this shape, I'm going to have, we said this side is square root of 3 based on what I calculated. We said this was what? 2. This is what? 1. So what is the area right now of this shape? Area is going to be 1 over 2. What is base? Base is 1 times what is height? The height we calculated is what? Square root of 3. But if I just use this as the area, I'm making a big mistake, because look at, we have two different part of this, which is 17. So that means I can either multiply my result twice, or I'll calculate this and add with this. So this one is twice inside here. So I'll just multiply my result by what? 2. Oh, let me just make it this way. This is going to be this side. We said this is square root of 3. We said square root of 3. This is 1. This is 2. Area of this one also is going to be 1 over 2. What is base? 1 times what is height? Square root of 3. So this one is equals square root of 3 over 2. Something with this, square root of 3 over 2. But the thing is, we have to join this and this to get the total, or the big triangle we actually split it in the beginning. So to add this, I'll just let me make it this way. I'm adding it. If I add this result and this one to get that, I'm going to have this is equals square root of 3 over 2 plus square root of 3 over 2, which is equals to what? What's the LCM? 2. Then we have 2 into 2, that's 1. 1 times square root of 3, I have square root of 3, plus 2 into 2, 1. 1 times square root of 3, I'm having square root of 3. So my result is going to be what? 2 square root of 3 over 2. 2 we cancel 2. And the area of this is going to be what? Square root of 3. You can see how easy it is. So this is just the somehow complicated calculation of area of equilateral triangle. Had it been it's an isosceles triangle, let me form one instance of an isosceles triangle. Sorry, I don't mean to use this side. I think this will be okay. So for an isosceles triangle, we all know that isosceles triangle is just a triangle that only two sides are what? Equal. So let me try my best to draw that. I think this is an isosceles triangle. Yes. So if I have this, they actually look same, like I said, this that was an equilateral triangle. Pardon me. So for this one, I'm trying to say these two sides are equal, but this is not same as them. Let me give them 3, 3. Let me give this 2. So now you are told to calculate the area of this isosceles triangle. How do you do that? Just simple as that. Same technique. Construct a certain height, because the height is not given from the question. Construct a certain height. If you do that, we said the whole of the base is 2, right? So since the whole of the base is 2, we can actually split it. Just like how we did that. We can call this 1, 1, because 1 plus 1 is what? 2. So if I remove this portion, this very portion, I'm going to have something like this again, right? This is still the missing side. Let me call it A, because we don't know what this place is actually equals. So this side is what? 3. This is 1. So how do you calculate A? Remember the formula. A square is equals C square minus B square. So our a square is equals, what is c square? C square is 3 square. What is 3 square? That is 9 minus 1 square. What is 1 square? That is 1. So, sorry, we continue here. Our a is equals square root of 9 minus 1 is 8. So a is equals 8. Or I can write it in a radical form to be 2 root 2. This is my a. So since a is this is the missing side actually. The area of this triangle, if a is this, let me write this, 2 root 2. So at the end, I'm going to have that area of this is going to be 1 over 2 base, which is 1, times what is height. Height is 2 root 2. But remember, in the last example I did here, I said I, at the end, added the 2 results. So instead of adding, when I say I want to add 1 plus 1, it's simply as saying 2 times 1 of the quantity I was talking about. So for this very one, I'll just say times 2 again, because I'm going to do this twice, so no need. I'll just multiply it by 2. So from here, 2 we cancel 2. So the area is just going to be what? 2 square root of 2. So as you can see, if you observe this very well, I actually observe something here, because look at this. When we are trying to calculate the area of this shape, calculating the height just gave us the result to be square root of 3. Sorry, where is the height? We got the height to be square root of 3. And at the end, we got the result to be, when we calculated the area, we got that it's also square root of 3. That means when we have a certain triangle, be it isosceles or equilateral, calculating the height will determine what you got in the to be your area. Same thing with this, as you can see. We calculated that the missing side, which is the length, or should I say the height, which is a, is equals, we said 2 root 2. At the end, we still arrive at 2 root 2. So that means, does it mean that, let's look at something also. Pardon me, still have to clean this side. Let's assume it happens like that. Let's check it out. Let's assume I have a triangle like sorry, I'll assume I don't have the height. If there's no height, let's call, this is an, I want to talk about, this is an equilateral triangle also. So that means all the sides, let me give them 3, oh, sorry, it should be 4, 4, 4, for simplicity of when I want to split this. So the area of this, I have to split it into 2 again. Remember the technique? This is 2, 2. So assuming this part is just alone, I'm going to have something like this side is 2 because I splitted this. If I join it, is giving me the center. This is 4. I don't know what this side is. Same thing. So for the other one, this is still going to be, this is 2, this is 4, this is 8. Look at this. If I will just join it, I'll get back my triangle. So does that mean that calculating the area of one of the angle, I'm multiplying by 2? Or let me just, calculating the height of this triangle, is it actually the result of the area of the triangle? Look at what I mean. Let's calculate A. A square is equals C square minus B square. So our A square is equals, C square is what? 4 square, which is 16, minus B square. B square is what? 4, right? Because 2 square is 4, which is equals what? Is it 12? Yeah, 12. So we got our A is equals square root of 12, which is equals, how do you write 12 in a radical form, just like I did this? It's just, I think, 2 is 2 root 3 going to work? Yeah, 2 root 3, because 2 square 4. 2 root 3 is the is the side of A. So if I would just rewrite A to be 2 root 3, A to be 2 root 3. These are two different angles. To join it, I'll get this. So let's see. The total area is going to be area of this plus area of this. Area of this one is going to be 1 over 2 base, which is 2, times height, which is 2 root 3, right? Then I'm still adding normally plus this same thing, because it's same result, 1 over 2 times 2 times 2 root 3. So looking at this, 2 will cancel 2, right? So this is going to be 2 will still cancel 2. So I'm having 2 root 3 plus 2 root 3, which is equals 2 root 3 plus 2 root 3 is 4 root 3. So, I don't know what actually happened. I don't know if I have a mistake somewhere or not, but the result is actually different. That means my observation and what I was thinking is actually not true. We'll still see it in some coming videos